Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with 12th Standard Mathematics Paper 1, First Chapter, Mathematical Logic, Part 5. We already studied quantifiers, quantified statements, dual, etc. in the previous video. So today we'll start with the topics negation of compound statements. First one is negation of conjunction, negation of disjunction, negation of negation, negation of implication, negation of double implication, etc. So today we'll start with the first topic, negation of conjunction. Negation of P and Q is equivalent to negation P or negation Q. This is called De Morgan's law also. We already studied this in the previous video. The rule is this one. Negation of conjunction of two simple statements is the disjunction of their negations. Here P and Q are simple statements and negation of conjunction of two statements is equivalent to disjunction of negations of them. That is the meaning of this. We'll discuss with example. 6 is an even and perfect number. So we'll split the simple statements like this. P 6 is an even number. Q 6 is a perfect number. Symbolic form of the given statement is 6 is an even number and is given. So P and Q is the symbolic form. Now negation of P and Q you have to find out here. So negation of P and Q is equivalent to negation of P or negation of Q. Now we will apply the negations of the given statements in this result. So 6 is not an even number. Then we will put or in between this. Then not a prime number. Next is negation of disjunction. Negation of P or Q is equivalent to negation P and negation Q. The rule is this one. Negation of disjunction of two simple statements is the conjunction of their negations. That means P and Q are simple statements here. We are taking disjunction of two statements negation that is equal to conjunction of the negations of these two statements. Let's discuss with example. 5 is a prime number or 10 is a composite number. We'll split the statements first. So let 5 is a prime number and Q 10 is a composite number. Now we'll write the symbolic form of this one. So symbolic form of the given statement is P or is given. So P or Q. Now we have to find the negation of this one. So negation of P or Q is equivalent to negation P and negation Q. Again De Morgan's law. We have to write this result before writing the negation of the disjunction. Then only we'll write it correctly. So 5 is not a prime number and 10 is not a composite number. So we are just applying the negation of the statement P here and you are putting the conjunction symbol. Then you are putting negation of the second statement. So first you will write the rule, then we will apply the statements. Next is negation of negation. The negation of negation of simple statement P is P itself. That is, negation of a negation statement is equivalent to the statement itself. Example, let P is equal to 2 is an even number. So only one statement we have required here. So I have written. Now negation of P is 2 is not an even number. So negation of negation P is 2 is an even number. The statement itself. This you can write in other way also. It is not true that 2 is not an even number. So in the given statement, it is not true that is a negation and not is applied again. So 2 times negation, if you are applying in a sentence, it will become positive sentence. Or you can write like this also. It is false that 2 is not an even number. This is the truth table of this one. You can see it. So P, negation P, negation of negation P. So P value true and false. Negation of P is false and true. So negation of negation is true and false. So the first column and third column are same. Truth table of conditional. Now in this one, PQ have to write like this. PQ statements are there. So 2 statements at 4 rows will come. You have to write like that. Then negation P is false, false, true, true. Then P implies Q is true implies true is true, true implies false is false, false implies true is true, false implies false is true. Now negation of P or Q is negation of P is this one and Q is this one. So we have to take or in between this one. So false or true is true, false or false is false, true or true is true, true or false is true. So from column number 4 and column number 5, you can write P implies Q is equivalent to negation P or Q. So we are proving through truth table this result. So P implies Q can be written in this form, negation of P or Q. This result we are going to use in the negation of implication. The negation of conditional statement. We have this result now, we already proved now. So P implies Q is equivalent to negation P or Q. So negation of conditional is negation of P implies Q. You can write this statement here. So negation of P implies Q is equivalent to, you have to write negation of this statement. So negation of negation P or Q. We all know that negation of negation P and negation Q. You will apply negation to both the statements by using De Morgan's law. So I have applied that here. Now negation of negation P is P and negation Q as it is. So negation of conditional statement P implies Q is equivalent to P or negation Q. So you have to by heart it. This and this both you have to by heart it. P implies Q is equivalent to negation P or Q, and negation of P, either of this one you have to by heart it so that you can write the second one easily. Example, if more trees are planted, then we get greenery around us. If then is used, so it is definitely implication. So P is more trees are planted. You will not write if in statements, simple statements. This is the connective we are applied in this two simple statements. So we have to remove that before writing P and Q. And Q is after then we will get the second statement. So we get greenery around us. So symbolic form of this given statement is P implies Q. Now negation of P implies Q is equivalent to P and negation of Q. We already studied now. Now we will apply the statements values in the place of P and negation Q. So P value is more trees are planted. And or but, anyone you can apply. So but we do not get greenery around us. We applied negation to the statement, second statement here. So this is the answer for the given question. Next one, truth table of biconditional. To prove truth biconditional negation, you have to first find this value again. So truth table important है. So first one, truth table of double implication. So here again P, Q we are writing as it is. Now P if and only if Q or P double implication Q you have to find. So true if and only if true is true, true if and only if false is false, false if and only if true is false, false if and only if false is true. P implies Q you have to find here. So true implies true is true, true implies false is false, false implies true is true, false implies false is true. Now Q implies P you are finding here. So first you will take the values of Q. So true implies true is true, false implies true is true, true implies false is false, false implies false is true. Now from column number 7 and 8, we will take the conjunction of these two. So true and true is true, false and true is false, true and false is false, true and true is true. So we can write from column number 5 and column number 9, both the values are same. So before finding negation of biconditional, you have to by heart this result. So P if and only if Q is also equivalent to P implies Q and Q implies P. So you'll apply this result in negation of biconditional. So we are taking this. Now we have to apply negation on both sides of this one. So negation of P if and only if Q is equivalent to negation of the entire statement pattern you will write. Next step you will write negation of P implies Q or negation of Q implies P by De Morgan's law. Now both the statement pattern negation of P implies Q is negation of conditional statement and negation of Q implies P is also negation of conditional statement. We will apply that results here. So negation of P implies Q is P and negation Q, or negation of Q implies P is Q and negation P. Now this is the result you have to by heart again. So negation of P if and only if Q is equivalent to P and negation Q, or Q and negation P. Now example. The number is an even number if and only if it is divisible by 2. Again, we will split this P and Q. So P, a number is an even number. Q, number is divisible by 2. Now, symbolic form of the given statement is this one. P if and only if Q. After applying this rule, we have to just write this. So, a number is an even number. We have given the value of P here. And, or but you can apply not divisible by 2, the second statement negation we have written, or a number is divisible by 2 and or but you can apply not even, that is written over here. Now examples, write the negations of the following statements. It is very simple. The number is neither odd nor perfect square. So we will split like this. Here in the statement there are two negations are there. Neither nor is applied. So we will put the number is odd is the first positive statement and Q is the number is perfect square. Symbolic form of the given statement you have to write. So negation P and negation Q. Now negation of this one you have to apply. So negation of negation P and negation Q is equivalent to P or Q. Now we will write the values over here. So the number is odd in the place of P or perfect square in the place of Q. Next is x plus 8 greater than 11 or y minus 3 equal to 6. So in this way you can write like this. So P x plus 8 greater than 11, y minus 3 equal to 6 is the second one. Then symbolic notation you will write. The negation of P or Q is equivalent to negation P and negation Q. Now we will apply this result in this one. So we'll get like this. Root 2 is a rational number. This is a simple statement. Only P is given. So negation of P is root 2 is not a rational number. Now some exercise questions are given to you. You have to solve it. Thank you.